Welcome to the Deep Dive, where we cut through the noise to get you well-informed fast. Today, we're plunging into something pretty striking, actually. Back in 2004, the UN Security Council adopted Resolution 1540. That was all about combating weapons of mass destruction, your
Hmm.
nuclear, chemical, biological threats.
Right, the big ones.
But the idea that artificial intelligence might interact with all that, it wasn't even contemplated, just not on the map.
And now, well, fast forward just a couple of decades, and the UN Secretary General is expressing deep alarm. It's quite the turnaround.
Deep alarm, that's strong language from the UN.
It is, and they're specifically pointing to AI intersecting not just with nuclear weapons, which is scary enough, but also biotechnology, neurotechnology, even robotics.
Wow. So the landscape has just completely shifted, hasn't it?
Dramatically. What wasn't even a thought experiment is now a top-level concern.
Okay, so for this deep dive, that's exactly what we're exploring. This critical and maybe alarming intersection of AI and global security.
Hmm.
We'll be drawing on those foundational UN resolutions, but also, like you mentioned, some really cutting-edge research. There's a big white paper from the European Defense Agency on trustworthiness for AI in defense.
Yeah, that one's key.
So our mission today is really to unpack this. How can AI amplify the WMD risks we already knew about? And what entirely new hazards might it create?
And what are the gaps, in international governance? Are there any rules for this stuff?
Right. And then look at the flip side. The huge efforts going into making AI in defense not just powerful, but, well, trustworthy.
Which leads to that big question.
Yeah, what does it actually mean to have meaningful human control when things are getting more and more autonomous? Let's try and unpack that.
Okay, let's dive straight into those alarming intersections then. Starting with AI and WMD proliferation, especially thinking about that 2004 Resolution 1540.
Its original aim was pretty clear, right? Reduce the threat of WMDs, nuclear, chemical, bio, and how you deliver them.
Straightforward enough back then.
But AI, like we said, totally unforeseen. So how are later UN resolutions starting to deal with AI's potential adverse effects on what 1540 was trying to do?
Well, they've had to acknowledge it, haven't they? Later resolutions explicitly mention these potential adverse effects on both how 1540 is implemented and its outcomes. The core argument you see in the sources now is pretty stark. AI can amplify the risks that were already there.
Making existing problems worse.
Exactly. And it can also generate novel hazards, things we haven't even properly considered before. Both of those obviously exacerbate threats to international peace and security.
And when we talk about AI's role here, it seems particularly dangerous when you get to autonomous decision-making systems actually controlling WMDs.
That's the nightmare scenario, isn't it? Algorithms selecting and attacking targets without direct human control in the moment.
From a technical standpoint, what are the biggest worries there?
Well, there's this huge potential for unintended negative consequences. If an AI encounters a real-world situation it just wasn't trained for.
Something unexpected.
Right, it could lead to absolutely catastrophic harm. Civilians, critical infrastructure, the collateral damage could be immense and unpredictable.
And that raises huge ethical questions too, surely.
Oh, absolutely. Can we even build an AI that consistently upholds ethical principles? Human rights, the sources are pretty blunt about this. They say it's enormously difficult. People are trying to create, ethical machines. But these efforts, they usually still need human supervision and are frankly, quote, full of weaknesses.
Full of weaknesses. That's not very reassuring when WMDs are involved.
Not at all. And then there are the legal questions. Who's accountable if an AI makes a disastrous decision? What are the legal obligations? These things get incredibly tangled, almost impossible to sort out sometimes.
Okay, so that's autonomous weapons. But what about generative AI, GAI? The kind that creates new content, text, images, audio. How does that fit into the WMD risk picture?
Right, GAI is different. It doesn't just analyze, it creates. And it can create incredibly convincing stuff. That makes it a really powerful tool for, well, bad actors.
Like for propaganda.
Exactly. It can facilitate extremist propaganda, maybe by desensitizing individuals. You can imagine interactive social media, music, video games, pushing extremist views, letting people sort of identify with violent perspectives.
That's insidious.
It is. And it's not just hypothetical. GAI is being used to generate conspiratorial and violent digital content for political extremists. The Global Network on Extremism and Technology confirms that.
Even the big AI developers are worried, right? OpenAI.
Yeah. They put out a preparedness framework in late 2023, and it explicitly lists AI-assisted creation of WMDs as a risk category.
Okay, that sounds bad. How high do they rate that risk?
Currently, they assess it as low, sort of similar to the risk from just using search engines, they say, but
That's always a but.
there is. The really alarming insight isn't just that the risk level could change, it's how fast it could change. A small breakthrough in a seemingly unrelated field, material science, synthetic chemistry, whatever, could suddenly make that low risk skyrocket. It's the interconnectedness of AI's potential with other fields. That's the sleeper issue. And OpenAI themselves say this assessment is prone to revision. It could change quickly.
So if AI is amplifying risks, creating new ones,
Yeah.
where's the global response? It sounds like there's a huge gap here.
You've hit the nail on the head. The sources point squarely at a significant governance vacuum.
A vacuum, meaning
Meaning there's a real lack of international multilateral agreements or any existing governance framework that covers the use of AI in the military. It's kind of a Wild West situation.
what does that mean in practice, having no framework?
It means we're basically playing catch-up. We're reacting to developments rather than proactively shaping them, which is why there's this strong recommendation to broaden the scope of UNSCR 1540. Make it specifically cover AI's impact on developing, distributing, and proliferating WMDs. Bring AI explicitly into that existing framework.
Are there any efforts happening, even if not global, national or regional?
There are some. It's not a total void. The European Union's AI Act is a big one. Now, it specifically excludes the military domain.
Okay, so it doesn't apply to defense AI.
Not directly to purely military systems. However, it does require dual-use AI systems, ones that have both civilian and military uses to comply with its high-risk provisions.
So some oversight for certain types of AI, even if they have military application.
Exactly. It provides at least some level of ethical and legal checks for those systems. It's a start, even if it's not the comprehensive global solution we probably need.
Right. Okay, so we've looked at the risks, potential for disaster.
Mm-hmm.
It's easy to feel a bit, well, doomed. But people are working on solutions, right?
Absolutely. There's a lot of effort going into how we can actually build trust into these systems, especially for something as critical as defense.
Which brings us to that European Defense Agency work you mentioned. Their TATE initiative, Trustworthiness for AI in Defense.
Mm-hmm.
What's the goal there? Is it about setting hard rules?
Not exactly rules, more like food for thought, as they put it. It's an approach aimed at EU member states, particularly their ministries of defense and also the defense industry, giving them a framework to think about as they develop future AI systems.
Food for thought for the MODs.
Uh-huh.
And just to be clear, what definition of AI are they working with?
They use the OECD definition. Basically, an AI system is a machine-based system that infers from the input it receives how to generate outputs. It learns and acts based on data.
Okay, so the EAA is trying to guide the development of these inferring output-generating systems for defense, making them reliable, safe.
Exactly. Especially because the military context has such incredibly high stakes.
Now, this next point feels really crucial. The unique nature of military AI. There's this tension you mentioned.
Yeah, it's a big one.
How do you possibly balance the need for transparency and accountability, things we generally want from AI, with what the military often needs? Secrecy, autonomy, and rapid decision-making. How does that play out?
It's a fundamental conflict, really, because those requirements often pull in opposite directions: transparency versus secrecy, accountability versus autonomy speed. And this tension really comes into focus with the idea of the operational design domain, or ODD.
ODD, what's that?
It's basically the specific set of conditions an AI system is designed to work safely and effectively within. Think of it like the operating manual's limits.
Okay.
Now, for civilian AI, like in commercial aviation, the ODD is usually expected to be pretty static, right? Flight paths, weather conditions, airport procedures, they're known, regulated, predictable.
Makes sense?
But for military use,
Right.
the ODD as operated is way more dynamic. Why? Because of the unpredictable and adversarial nature of the environment.
The enemy.
Exactly. The enemy is actively trying to conceal things, to deceive, to change the conditions. They're designing the environment to fool your sensors, to disrupt your plans. So military AI has to be able to adapt constantly to situations it might never have seen before, situations designed to trick it.
That sounds incredibly challenging.
Yeah.
And adaptation needs data, right? Which leads to another problem you flagged.
Yes, the data challenge in defense. AI models, as we know, usually need huge amounts of data, accurate, complete, timely, representative data to learn properly.
The more data, the better the AI. generally speaking.
Right. But military data, it's often the opposite. It's considered scarce, incomplete, or too specific.
Yeah.
You might have very few examples of a particular type of event, say a specific kind of missile attack.
Not like training facial recognition on millions of internet photos.
Not at all. And the data you do have is often highly classified, restricting how it can be used. Plus, because the environment changes so fast, new tactics, new equipment, existing data sets can become obsolete very quickly. What worked last year might not work this year.
So if real data is scarce and gets outdated, how do you train these things?
Well, they're looking at a couple of main solutions. One is synthetic data generation.
Making up data.
Essentially, yes. Using algorithms to create artificial data that mimics real-world scenarios. But the key there is you need really good ways to measure if that synthetic data is actually accurate and representative enough. Quantifiable performance indicators are crucial.
Okay, synthetic data. What else?
The other approach is developing frugal AI models. These are models designed to learn effectively even with minimal data. They might use techniques like transfer learning.
Where you take a model trained on one thing and adapt it for something else.
Exactly. Leverage knowledge from data-rich areas for data-scarce military applications.
It's interesting. You mentioned deception earlier, the enemy trying to fool the AI. The source even mentions things like painting tanks pink.
Huh. Yeah, that example illustrates the point well. It sounds a bit absurd, but it highlights that human ingenuity for deception, for finding ways around detection, will likely never stop.
It's a continuous cat and mouse game. The AI adapts, humans find a new trick.
Absolutely, which reinforces just how dynamic and challenging that military ODD really is.
And then there's another practical headache.
Yeah.
Dual compliance.
Right. Imagine a military drone. In peacetime, maybe it's used for border surveillance, it might need to comply with civilian aviation rules, data privacy laws, maybe even parts of the EU AI Act if it's dual use.
Okay.
But then in wartime, its mission changes completely. It operates under different rules of engagement, different legal frameworks. The AI system has to potentially function under both sets of constraints. Balancing that, it's really complex, almost like needing two different personalities.
Okay, so given all this complexity, the dynamic environments, the scarce data, the constant deception, the dual compliance, it really makes you wonder, how on earth do you start building trust into these defense AI systems?
It's a huge undertaking, and the EDA white paper digs into this with something they call the W-shape engineering lifecycle.
The W-shape, what does that involve?
It covers different types of AI, machine learning, symbolic AI, hybrid approaches. But the key takeaway isn't just a linear process. Think of the W-shape as representing cycles of development, integration, testing, and refinement.
So it's iterative.
Very much so. It recognizes that AI isn't just a component you plug in. It's part of a larger system, interacting with hardware, software, and crucially, humans. The W reflects that back and forth. You design the AI, you integrate it, you test how it performs in the system, you learn, you refine both the AI and the processes around it. It's a continuous feedback loop.
That makes sense. It's not just about coding the AI right initially.
Exactly. And that leads to another important shift, the focus on assurance. Traditionally, engineering focused heavily on development assurance, making sure you build the thing right, minimize errors during creation.
Getting it right on the drawing board.
Right. But for AI, especially autonomous military AI operating in those unpredictable environments, there's a growing emphasis on runtime assurance.
Runtime assurance, meaning...
Yes. Meaning ensuring it behaves correctly while it's running, during execution. Because things will go wrong. Unforeseen situations will arise. So runtime assurance involves things like real-time monitoring, checking if the system is still operating within safe parameters, assertion checking, and having strategies ready to recover or fail safely if it goes off the rails. It's about building in resilience for when things don't go according to plan.
Okay, so engineering for trust involves these complex life cycles and runtime checks. But trust isn't just technical, is it? There's a huge ethical dimension.
Absolute fundamental. And the EDA adopts 7 key ethical requirements for trustworthy AI, borrowing from the EU's wider ethics guidelines.
What are those? Can you give us the gist?
Sure.
Yeah.
It includes human agency and oversight, keeping humans in control. Technical robustness and safety, making sure it works reliably and securely. Privacy and data governance, handling data responsibly. Transparency, understanding how it works. Diversity, non-discrimination. Fairness, avoiding bias. Societal and environmental well-being, considering the broader impact. And accountability, knowing who is responsible.
That's quite a list.
It is. And the crucial point the sources make is that these aren't separate boxes to tick. They're interconnected. They need to be considered throughout the AI's entire life cycle, from concept to retirement.
It's not just a final check.
Definitely not. But it goes even deeper than a checklist. The sources talk about needing a more philosophical approach to, discussing something called value-based engineering, or VBE.
Value-based engineering, what's the idea there?
The idea is to get developers thinking proactively about values and potential ethical dilemmas during the design process itself, not just reacting after something goes wrong.
So trying to build ethics in from the start.
Exactly. VBE encourages developers to actively ask themselves, what human values could this system impact? How can we design it to uphold values like fairness or dignity, even under pressure? It starts early, maybe with a concept of operations document.
The ConOps.
Yeah, where you explicitly imagine the global impact. If this system were used everywhere by millions, what are the potential good and bad consequences? Think big picture from day one.
That's a really interesting way to frame it, thinking globally from the start.
It forces a broader perspective on potential ethical pitfalls.
And to help with this, they propose a specific role, the value lead.
That's right. This isn't just an ethicist offering advice from the sidelines. The value lead is envisioned as an accredited expert, someone who knows values, ethics, philosophy, but is also technically proficient. They understand the engineering.
So they can speak both languages, ethics and engineering.
Precisely. They're embedded within the system engineering team. Their job is to translate those abstract ethical principles into concrete design choices and technical requirements. They're constantly asking, are we truly embedding human dignity here? Is accountability traceable in the code? How does this design choice impact fairness?
That sounds like a challenging but vital role.
It bridges that gap, which brings us back to that core challenge. Meaningful human control, or MHC.
Right, MHC. You said it's contentious. Why?
Because it's incredibly complex. It's not just about having a human physically able to press an off switch, though that's part of it. It involves ensuring the human actually understands what the AI is doing and proposing to do.
Comprehension.
Yes. Ensuring the AI operates within clear boundaries set by humans. And crucially, ensuring a human retains the ultimate legal and moral responsibility and the practical ability to intervene and direct the outcome, especially when decisions have lethal consequences. Defining and implementing that technically and operationally, it's one of the hardest nuts to crack.
And thinking about that human role, there's a shift mentioned in how we view errors, moving from blaming human error to seeing it as socio-technical systems error. What's the significance of that shift?
It's a really important reframing. It acknowledges that in these complex systems with humans and AI working together, failure is rarely just one person's fault or just the AI messing up.
It's the interact.
Often, yes. It's a breakdown in the system. Maybe the human misunderstood the AI's display. Maybe the AI misinterpreted the human's command. Maybe the procedures weren't right. Maybe the training was insufficient. Maybe the environment changed unexpectedly. It forces you to look at the whole human-machine team and the context, not just point fingers.
So how does that change how you design things?
It means you have to focus much more on the integration and the interaction. You need clear human factors requirements. Things like defining roles and responsibilities very clearly for every level of autonomy, making the AI's reasoning transparent enough for the human to actually exercise meaningful control, and providing regular, realistic training so operators truly understand the system's capabilities and limitations.
Building the team, not just the tool.
That's a good way to put it.
Okay, so we have these engineering processes, ethical frameworks, human factors. How do you ensure consistency and actually verify this stuff works?
Well, standardization is key. The sources recommend developing a standardization management plan specifically for AI in defense.
What would that do?
It would identify existing best practice standards that can be applied, but also, crucially, identify the gaps where new standards are needed for AI's unique challenges.
And testing. You can't just test this stuff in a lab, surely.
Absolutely not. There's a big need for suitable test centers. These need tailored frameworks and infrastructure specifically designed for testing AI, especially in simulated but realistic operational environments.
Places to really put these systems through their paces.
Exactly. And the EDA, for instance, already has a network. Over 300 military test centers across the EU. The idea is to leverage and potentially adapt these existing facilities for the specific needs of AI testing. Rigorous, realistic testing is vital for building trust.
Okay, we have covered a lot of ground here, from the initial shock of AI impacting WMDs to the detailed work on building trustworthy defense AI.
It's a huge topic.
It really is. So just to kind of synthesize, AI is clearly at this critical point. It can escalate global threats, the WMD risk we talked about, but it also offers potentially huge advancements in defense capability.
It's a double-edged sword.
And the key seems to be navigating this incredibly complex mix of regulation or lack thereof ethics and the sheer technical difficulty. The goal is AI that's effective, yes, but also trustworthy, transparent, and ultimately under meaningful human control.
And it's clear that while the big international agreements are still a lot of align the technology.
The governance vacuum.
Right. But organizations like the European Defense Agency are actively trying to define the how. How do we actually build this stuff responsibly? With detailed engineering life cycles, ethical guidelines woven in, robust testing.
It's very much an ongoing journey, isn't it? Trying to lay down tracks for a train that's already moving very fast.
That's a good analogy. Creating that foundation of trust is paramount, especially given the stakes.
So as we wrap up, here's something to maybe leave you thinking about.
Yeah.
We've talked a lot about dynamic military environments, the push for more AI autonomy. So what happens? What ethical conflicts might erupt when an AI system, designed with all the best intentions in VBE, encounters a totally novel scenario, something completely outside its training data?
A true black swan event.
Exactly. And it has to make a split-second decision. Maybe a choice between achieving its mission objective and strictly adhering to an ethical value, like absolutely minimizing collateral harm. How can we even prepare the human in the loop for that kind of impossible choice? Or can we design the systems themselves to somehow prevent those dilemmas before they happen in the real world with real consequences?
That's the multi-trillion-dollar question, isn't it? How do you truly design for the unknown unknowns in ethics and warfare?
Something to chew on.